Hey everybody, I'm Simon Feltz, Engineer Manager at Canonical and responsible for Anbox Cloud. Today I would like, together with John O'Neill from Ampere Computing, introduce you to what we have worked on together to help building efficient and performance solutions to run Android in the cloud. Android is, as you know it, is traditionally known to run on smartphones, tablets, TVs, and nowadays even cars. Like I guess most of us will have an Android phone in our pockets. But besides running Android on physical devices, throughout the last years, various new use cases have been coming up. This includes like cloud gaming, offloading compute of typical Android applications to the cloud for higher efficiency, access to enterprise applications which have formerly been running on physical devices to cloud instances, for example, for data protection. But also offers the ability to keep legacy Android applications alive, right? It's like we don't have to run older Android versions on physical devices anymore. We can safely run those on cloud instances and just provide remote access when necessary. Furthermore, there's also like the automation of applications for all kinds of different use cases. And we have seen various startups in the past 2 years coming up and really trying to find new ways of how applications can be utilized. And this is describing this. And then what Android in the cloud is traditionally being used for is testing of Android applications, right? It's like testing an Android application you may develop, which you want to test from different angles, or you want to run at scale to test your backend services. That's also another use case where Android is typically being used for in the cloud. However, covering all of these use cases, there is a set of unique challenges which need to be solved. There's on the one side, you require high performance, specifically when doing cloud gaming. Like you may have more advanced game titles which really require adequate CPU and graphics performance. And then to really be cost efficient, as servers provide a lot of compute, you also want to run those Android instances at high density. Then second, as Android is naturally like mostly running on ARM devices, full ARM compatibility is required. There are binary translation solutions out there which all come with their different caveats and performance overhead. So ARM compatibility is required. Then third, what is also highly important if we're talking about cloud is running on enterprise class hardware, which means that servers are efficiently being made, they can be operated in the usual ways, and so on. On the software side, there are a few additional aspects as well, which include, like as written here, the containerization of Android. But as Android is usually being run on physical devices, running it in the cloud requires either virtualization or containerization to run it at higher scale or higher density. And then the last 2 points are going more together is first-class GPU support. Specifically for cloud gaming use cases or remote access to Android instances running in the cloud. Support for efficient graphics is required specifically for low latency video streaming. So coming all of those different challenges together, there are solutions necessary, both from a software perspective and also from a hardware perspective. And together with Ampere Computing, we have worked on something which has both those challenges solved. And I'm going now to talk about what we have done at Canonical to solve the software part. So Anbox Cloud is a product which we have developed at Canonical since 2017. And as many of you will know, Canonical is a company behind Ubuntu, so we're doing everything around Ubuntu. And we have a lot of different technologies to help our customers building efficient solutions running on any kind of cloud. So we thought like bringing all of that together, combining it to a great solution, which then also can help customers building out Android in the cloud solutions, can be very valuable. And that's what has become Anbox Cloud. The key aspects of Anbox Cloud is really to provide our customers with a solution which provides high scalability at high density, meaning we scale to an entire data center if necessary, but we also scale to a single machine if that's the purpose. And then at the same time, not just running a single Android instance on one machine, but providing higher density as the hardware allows. This is specifically necessary where cost is an issue, and the actual cost needs to be driven down. Third, what was always important for us when we developed Anbox Cloud is that it's a production-ready solution which can run on any cloud. It's either public or private cloud. It doesn't really make a difference for us. And if you want to do this for prototyping, if you want to do this to run a production system, it's ready for both, and Canonical provides support for all of this. And then last, what was also important since the beginning for us, that we are working very closely with silicon and cloud partners, specifically in this case today, Ampere Computing, to have the solution optimized. Because from the unique challenges I've described before, there are various aspects which can only be jointly worked and solved together in hardware and software. So I'm happy that we can present those results we have worked on with Ampere Computing today. If we are just looking at Anbox Cloud as a product, there, from a technology standpoint, as I mentioned, like it's based on Ubuntu plus the generic Ubuntu kernel we ship. There are Android-specific changes in that kernel, which we have pushed into the standard Ubuntu kernel, which make an Anbox Cloud possible. But other than that, it's just a standard Ubuntu kernel, which you run on every other Ubuntu device. Is it a laptop or is it a server as well? We are using the LXD container hypervisor to run containers, and our Android is also running in these containers. So like we have a pretty great solution here to run all of these containers pretty efficiently and also highly secure. And we will see how that works in the next slide. But before we come to that, there are a few more aspects I wanted to go on. Anbox Cloud runs natively on ARM. As I've mentioned before, running on ARM is highly important as the Android ecosystem is primarily focused on ARM. With that, we have no emulation overhead, right? It's like we are using containerization, like all of the processes from the Android operating system running natively on the CPU. There is no virtual machine overhead in any sense. Which provides us high performance for all of these Android instances. For us at Canonical, it's important that customers stay supported with the products we build. We ship latest Android versions with security updates included. That means every month we're doing a patch release, including the latest Android security patches, so that the Android versions which customers are using are up to date and also secure. We have built various specific optimizations into the system so that the containers run highly optimized. From both perspectives, from a density perspective, but also from a performance perspective. If you're providing remote access, we are a streaming solution. It's highly important that you do that. By default, Android is already highly optimized for various use cases. But for a cloud type of use case, there are additional optimizations necessary, which we have built here into Anbox Cloud. Then furthermore, like we covering all of the management aspects of how you would run such Android containers on any cloud, but we are also providing a streaming step on top, which provides low latency video streaming of the Android containers. Basically providing you access from everywhere in the world to those Android instances for use cases like cloud gaming or running any Android application as you like. In the solution we are presenting here today with Ampere Computing, we are using NVIDIA GPUs, but generally we are agnostic to the GPU being used. Yes, so that's about Anbox Cloud itself. If we are looking a little bit further under the hood of what it actually includes from a technology standpoint, we're really running the Android open source project as is, with a few changes to make containerization optimized and possible. But otherwise, our intention is not to deviate from AOSP. We just run it as normal. There are both use cases possible. You can either run a single application in foreground in what is called a kiosk mode, so that no other applications can run next to it, but you also can run a fully virtual device where you just have the Android launcher and all other Android applications accessible as normal. The Android, as I mentioned before, is highly optimized for performance and density and for fast startup. And we put like optimization specifically for ARM in here as well, and worked on various together with Ampere Computing too. In terms of the containerization itself, I've mentioned we are using LXD for the containerization, and LXD is a container hypervisor which focuses on what we call system containers. It's different from what you may know from container runtimes like Docker, where Docker's focus is primarily to run single processes in a container, and LXD is focusing on entire operating systems. That basically means any Linux-based operating system minus its kernel is running in LXD containers, and that very secure. All of these containers are running fully unprivileged, which means that root inside the container is not root on the host, but running as an unprivileged user, which provides high security. That has full integration for NVIDIA GPUs, so that the Anbox runtime, which is running inside those containers, can make full use of the NVIDIA GPU driver for both rendering and video encoding or decoding. What I've named here the Anbox runtime is really an abstraction layer we have built into the container, which basically abstracts the Android container from any hardware access and makes it possible to integrate a streaming stack, either ours or some customers bring or develop themselves. It provides, on the one side, as I mentioned, hardware abstraction, so like it provides input for all kinds of different input devices to Android, for sensors, for location, for camera, but it also establishes a low latency WebRTC video stream, which then can be consumed from any device. Is it a phone? Is it a tablet? Is it a computer? Basically everything which can receive a WebRTC video stream. To make it possible for clients to easily receive that, we have SDKs both for web and native, which makes that possible. Yes, and with that, I hand over to John.
Thanks, Simon. Hi, I'm John O'Neill. I'm a software engineer for Ampere Computing. I've been with Ampere for just a little under 3 years now. So Ampere Computing was founded by Renee James about 4 years ago, and the goal for Ampere was design CPUs for the modern cloud. So I'll kind of talk what the modern cloud CPU needs are and the features of Ampere Computing, and how that ties into having CPUs that are perfect for running Android in the cloud. I think when people stop and think, the cloud service providers, performance obviously is a critical feature they need. In addition to performance, having consistent performance is critical. If I rent a VM to run my application from a cloud service provider, I don't want the performance of my application to be impacted by what another customer might be running in a different VM within the same CPU. So the features that Ampere processors have for this are consistent CPU frequency. So the product was designed to run at full CPU frequency without the need to throttle the CPU frequencies down when all the cores are running. So a second feature within the cores was that they were designed for single-threaded hardware cores. So the performance of my application isn't going to depend if there's other hardware threads running and one particular one gets stalled. So having consistent performance with one single core is another feature that we enable this. Full ARM compatibility is important for running Android in the cloud, and this is perfect as Ampere has native ARM processors. So we run natively the operating system as well as 64-bit and 32-bit applications. So there's no need for any binary translation. We just natively run everything. Enterprise class hardwares is important when you're standing up large numbers of Android in the cloud virtualized instances. Our platforms have server class RAS features. And so the last item that Simon mentioned for hardware was, supporting GPUs, and our platforms have large I/O capacity as well as bandwidth, and so this allows us to, support greater number of GPUs, and which we'll be talking about that more in the rest of my slides. Moving on to the next slide, talking a little bit more details about Ampere processors and our platforms that are designed specifically for Android in the cloud with the GPU support. So I mentioned that Ampere designs processors for the cloud. So what we call cloud native processors. So basically the requirements for the cloud was, what we were designed for. So predictable performance, I talked about that on the previous slide. I think in addition to what I mentioned, having large caches and high memory bandwidth as well as I/O bandwidth is something that was designed into the product to enable the consistent performance. And we'll be showing results running Anbox on Ultra processors later to show this. Platform scalability. The one thing I didn't mention on the previous slide was Ampere Altra processors have the leading number of cores per rack. So basically, the amount of density you can fit in a server rack is industry leading with Ultra. And in addition to having great performance, having power efficient performance is also critical for cloud service providers. So our processors run at significantly less power than our competition. So I talked about Ampere Altra, 80 core parts, and that runs up to 3.3 gigahertz. The Ultra Max, which I mentioned is coming out this year, will have 128 cores, and this will be running up to 3.0 gigahertz. I think the other thing I'd like to mention is Ampere announced that our next generation product, which will be released the following year, this is going to have an Ampere designed CPU core. This is going to be fully ARM ISA compliant, and one of the things we're working on, in addition to improved CPU performance, is improved memory and I/O and network bandwidth. So that's something to stay tuned for in the future. Ampere Computing has a robust roadmap for each year having a different product come out. So very exciting times to be working at Ampere. So I'll call out two platforms in particular that I wanted to talk about for Android in the cloud. The first one is the Gigabyte Mount Snow GPU platform. This is a single socket, one processor platform, and this was designed to have up to 4 single width or dual width GPUs. Another platform we're enabling Android in the cloud is the Foxconn Mount Collins GPU platform, and this is a dual socket, so 2 CPU cores. And this actually the bigger platform will have greater GPU capabilities. This will be allowed up to 6 single-width GPUs, 3 dual-width GPUs, or 8 smaller half-width, half-height GPUs. So large GPU capacity, which I alluded to earlier in my presentation. Next, I'd like to talk about our initial results of running Anbox Cloud. We've been collaborating with Simon for a very long time to get Anbox running on Ampere products. So this is running Anbox Cloud 1.10. This is running on Ubuntu 20.04. And this is running on a single socket Ampere Altra 80 core platform. So this is using 2 NVIDIA T4 GPUs. So this is just our initial results. We're also working to scale this out to greater number of GPUs. We're running the Bomb Squad game in a special demo mode where the game runs automatically, which is great if you want to scale out to large number of instances for your platform, and repeatable. So basically the demo mode runs the same thing every time. So on this particular slide, we'll show results for running Bomb Squad at 720p, 30 frames per second configuration. We are encoding and streaming the output. And what you can see here in the top right chart is looking at the frames per second across the number of Android virtual instances. And you can see that the performance is going to be greater than 30 frames per second until up to 44 containers where we're able to hit greater than 30 frames per second. And then it drops a little bit after that. On the lower chart, we're showing the CPU utilization. And so two things I'd like to call out about that is one, we're at very low CPU utilization. So at 44 containers, we're only running at 21%. This is of 80-core single socket product. And the other thing is that you can see that the performance is, it's basically linear as you increase the number of instances. And so this is in earlier slides where I was talking about how consistent performance is critical for Ampere for when we design the product. So it's great to see when we're actually running the product that in fact we are getting consistent performance. The next slide I want to talk about a little bit more about our initial results of running Anbox Cloud on Ultra platform. So there's very little, very low CPU utilization. So we're running in different modes. This is running at 1080p, 60 frames per second, 1080p, 30 frames per second, 720p at 60 frames per second. And on the previous slide, we talked about the results for 720, 30 frames per second. And the charts that I'm showing here, I just picked out two of these to fit on the slide. So basically, we're showing linear CPU utilization for all the cases. I only showed two here, but they're linear. So basically, we're showing, excuse me, we're demonstrating consistent CPU performance as we add more cores and more instances. And then the other thing is also we're very low CPU utilization. So we're working with Simon and the Canonical team is to increase the density. This is our initial results of running on Ampere Altra platforms. So we want to increase the GPU density and then look at what's the maximum number of instances we can do. I think both everyone is very excited with right now with 2 GPUs what we're able to achieve, and we're looking forward to adding more GPUs and seeing what the platform is fully capable of running. So now I will hand it over to Simon, who's going to give us a demo of running Anbox Cloud on Ultra processors. Here you go, Simon.
Thanks, John. So as John mentioned, I now wanted to just show a quick demo of Anbox Cloud running on an Ampere Altra system. So what we are looking at here on the terminal is an Ampere Altra Mount Snow system, which is a single socket with 80 CPU cores. It also has 125 gigabytes of memory attached. It also includes 2 NVIDIA Tesla T4 GPUs for all the graphics and video encoding. And it's already prepared running Anbox Cloud, and it's also running 44 instances of the bomb scrap game, which we have used for the benchmark data which John has shared. So if we just look at all of the running instances, we see like there are the 44 of those. We can just open a shell inside one of those containers, and if we look at the process list, we see all typical Android processes in there. We see Surface Flinger, we see all the different Android system services like the print service, we see Bomb Scrap the game itself. So it's really just an Android instance as you know it, as you run it on your phone. There's no real difference. And all of these 44 instances are set up to with a resolution of 720p and rendering at 30 frames per second. And they are also utilizing the encoder built into the NVIDIA Tesla T4 chips. So if we look at the NVIDIA SMI output, which is the tool you usually use to look at those statistics from the GPU, we see the GPUs are both being utilized on the rendering part at about 80 to 70%. And on the encoding side, they are also being utilized on about 40 to 50%. So we have some fairly good utilization on the system. And which allows us to achieve those benchmark results, which John has shown. So not just running all the containers, but we can also just look into one of them. So I've just opened what we call the Anbox Cloud dashboard in a standard Google Chrome browser here, which is connected over WebRTC to one of those containers. And I can just interact with the Android instance as you do with a regular Android. It's mouse input here, but on a phone or a tablet, it would be just regular touch input. And I can just play the game, cause some explosions, and actually lose. But you see, it's generally not much different to what you would actually see on a regular phone. And that's all from my side. Thanks a lot, John, and thanks everybody for watching. And if there are any questions, feel free to let us know.